Good morning, everyone. Welcome to the first Energy Talk. Today, we are pleased to kick off this action that we joined together with four projects are here kicking off. These energy talks are an ongoing series of collaborative discussions initiated by these four projects that we will be shortly introducing to you, funded under the same goal of Horizon Europe Cluster 5 Destination 3, namely i-STENTORE, Synogenes, Tulip, and Augustine, who aim to demonstrate and integrate innovative forms of storage into advanced energy systems and grid architectures. I would like to present to you the agenda of the day. So my name is Ana Luisa. Sorry, I didn't introduce myself. I am here representing i-STENTORE project together with my colleague Maria that you can see now. Hello, Maria. And to present the projects, we will have Nikos Bilidis, who is the coordinator of i-STENTORE, Gianluca Lipari, the coordinator of Augustine. Later, we will have Elias, who is the coordinator of Synogenes. And unfortunately, today we cannot have Lars from Tulip because he is ill, but we will try to give you some enlightful information about the project. Later on, we will have this great interactive discussion on the main topic of today, moderated by Rita Campus, who is a colleague at F6S, and also project coordinator at Exigence, another energy efficiency project. The panelists of the session will be Pedro Rodrigues, Gianluca, and Elias, and we will wrap up the session with a few notes and giving you next steps for this series of talks. Without further delay, I give the floor to Nikos. Go ahead, Nikos.
Hello, thank you, Anna. I hope you can hear me. So I'm Nikos Bilidis, and I'm an R&D project manager in European Dynamics, and also the coordinator of the i-STENTORE project. And today I will give a brief overview of our project, starting with a short fact sheet. So i-STENTORE stands for Innovative Energy Storage Technologies towards Increased Renewable Integration and Efficient Operation. The project started in January of 2023 and is going to run until December of 2025. So in total, it has a lifetime of 3 years, and the total budget of the project is in the order of 10 million euros, while the funding that we received from the European Commission is in the order of 8 million euros. So if we can go on to the next slide. I don't know, can I change them myself? No. Okay, thank you. So the main objectives of the project are to examine the integration of diverse storage solutions and their combination. So i-STENTORE examines various storage systems of different types and proposes hybridized solutions where storage systems are combined. In this way, we can exploit the combined advantages of storage systems and avoid certain limitations that the standalone storage systems may introduce. And the project also aims to examine the applicability of versatile storage solutions in different sectors, including but not limited to industry, mobility, agriculture, heating, buildings, and others. Also, the project will promote the introduction of innovative business models in order to foster the deployment of single and hybrid energy storage systems, aiming mainly towards the participation of storage systems in energy markets. i-STENTORE will prove how storage can be an active player in energy markets, and by providing products and services and ensuring new revenue streams for storage operators through the participation in different horizons and time frames of the energy markets. And finally, the project will facilitate investment planning on energy storage facilities. It will strengthen and expand the technological value chains on energy storage. If we can move on to the next slide, where we can see the general concept of i-STENTORE. So i-STENTORE will examine the integration of diverse energy storage solutions and their hybridization through advanced digital solutions that are going to be created within the project. We will showcase innovative energy storage systems and their cooperation with the integrated assets will be co-optimized, placing the reliability, the power quality, the cost-efficient operation, and the maximization of assets lifetime as end goals. i-STENTORE will introduce an umbrella framework that aims to showcase both standalone and hybrid storage solutions and highlight the multi-purpose use of storage, not only as an energy buffer, but also as an active grid component that is capable of providing services and contributing to grid resilience, stability, and efficient operation. The proposed framework will examine the applicability of the different storage solutions in various applications, creating what-if scenarios in order to select the optimal solutions for each application and promoting purpose-specific hybrid energy storage systems. To achieve this and to ensure a seamless integration in a technology and in a technology agnostic and interoperable manner, i-STENTORE will design a reference architecture for the development of a virtual power plant for storage systems, which will be our main digital component that will lie in the center of all applications. And as we already said, the project will introduce business models, but we are going to target positive and attractive business cases, promoting storage as a facilitator of the energy transition and taking care of all regulatory implications, different regulatory barriers that may exist currently and that hinder the widespread deployment of storage and the exploitation of all its capabilities, especially in the provision of services and the participation in markets. Next slide, please. Yeah, all these are going to be showcased in 5 demonstrations and a living lab. We have very big, large-scale demonstrations in i-STENTORE in 6 different countries. So we have a demo that deals with thermal energy storage in Slovenia. In Portugal, we have a combination of pump hydro and batteries, pump hydro storage system and batteries in Madeira. In Spain, we have a virtual energy storage system which combines different types of batteries, a vanadium redox flow battery and a lithium battery. In Italy, we have a cooperative modular multi-hybrid energy storage system that is based on hybrid supercapacitors and lithium batteries for smart DC multigrids of e-mobility, for e-mobility services. And in Luxembourg, we have an agri-PV farm which combines hydrogen storage and lithium battery storage. And in the living lab, we have small prototypes of all these technologies. So that's all from me in a nutshell. Here you can see the consortium, which is a quite extended consortium that consists of approximately 27 partners. And in the last slide, you can see our social media, and you are welcome to follow us and stay tuned with our updates. Thank you very much.
Thank you, Nikos. Thank you very much. We give the floor to Gianluca, please.
Yes, good morning also from my side. I'm Gianluca Lipari, technical leader at Apple Europe and the coordinator of the i-STENTORE project. I will as well give you a quick overview of the project today. And as anticipated, also i-STENTORE is funded on the same call as the other sister projects. We also started in January 2023. And in a very nutshell, our main goal is to look at industrial application or industrial use cases where the integration of storage, renewable, and industrial processes can be enhanced or optimized. If you go to the next slide, we have a set of specific objectives starting indeed from the innovative storage solutions and demonstrating how innovative storage solution can be integrated in industrial sites for providing flexibility, optimization, and grid services, together with the design of what we call AGI, or Advanced Grid Interface, that is meant for integrating seamlessly, easily and flexibly both the storage, the local generation, and the industrial process to enhance the economical and technical performance of the use case. We also look at different type of storage. So this solution is also meant for flexibly adapt to different types of storage and also renewable generation. What we also want to offer with this grid interface is grid services. So use the i-STENTORE solution not only to provide services to the grid user, the industrial user, but also towards the grid. We also try to look at different approaches for, of course, reduce material use and emissions. And finally, what we want to investigate is what business cases can be supported by the storage integration within the industrial process and premises. Of course, also the provision of the services to the grid, and see how the business model can support investment on the technology, both the interfaces as well as the advanced storage technologies. If we look in the next slide, what I'm presenting here is what we call, as anticipated, this advanced grid interface. So a common DC bus that we want to develop, where we can integrate the different assets. I mentioned the generation, local generation from renewables, the energy storage solutions, the different ones we are going to test in our demo sites and labs. And also the different industrial loads or industrial processes that we have in the demos. This common interface then has a single point of connection towards the grid, and it's where we want to provide grid services, for example, for frequency control or grid forming capabilities. And also, apart from the hardware component, let's say the physical components, we also develop a plant level control approach, where we can optimize the mix of generation and storage to support the industrial loads or the grid services, and also allow a flexibility and extendability of the concept. So having both physical components and control strategies and optimization strategies that allow the integration even in the future of new or additional generation or different sort of storage, or replicate the solution in other industrial environments. The next slide will show what are the three main storage solutions we're looking in the project. Referring to first is the aqueous electrorecuperators, which is the most innovative one we have in the project, which by characteristics is something in between a super cap and a traditional, for example, lithium-ion battery, which basically has the goal in one of the demos to support specific applications where, for example, the dynamics of the response are quite challenging, even though there is not much need of, for example, storage capacity, but dynamics are very important. We're also using redox flow batteries in the demos, as well as the irrigation system of the Spanish demo, where we want to use a pre-existing the industrial infrastructure of the irrigation canals and the reservoirs as a long-term storage. In fact, in the next slide, here I just present the two main large-scale demo. Before this, I just want to mention we also have 3 laboratory demonstration sites where we basically develop and validate the concept in a smaller scale. So we have 2 demo sites in Germany with 2 Fraunhofer institutes. One somehow related to the main demo of the green hydrogen production, and the other one on EV charging infrastructure, and the third lab demo in Spain, where we do the small-scale validation of the hydropower and irrigation community testing. And then we have these 2 main demos. The one on the left is about green hydrogen production in Shell premises in the Netherlands, where we want to use the AGI and the storage in combination with the local generation and the electrolyzer to, of course, facilitate and optimize the green hydrogen production, and also be able to keep the grid connection limitations imposed by the local operator, and to maintain the injection, specifically in this case, towards the grid at a minimum, or avoid it. While the second use case, the one on the right, is instead an irrigation community in Catalonia, where we have canals and reservoirs that serve the irrigation community, the local irrigation community. And there, again, we will use the local generation mainly from PVs and the grid connection to support the pumps and the irrigation facilities. But also we want to combine the AGI in a matter of trying to reduce by using also the storage, the short-term storage by the electrochemical storage, and the long-term seasonal storage given by the reservoirs, to try to reduce the costs, the operating costs of the community, which is the main goal of this demonstration. In the last slide, yes, I also included our social channels as well as the newsletter. So please also give a look at our website and follow us for also the upcoming activities.
Thank you very much, Gianluca. Thank you. Let's give the floor to Elias from Synogens, please. Go ahead, Elias.
Hello. Hello from my side. Thank you very much for the invitation. I'm Elias Zafiropoulos. I'm Technology Director at UPTech Energy, and I'm the Technical Coordinator of the Synogens project. I will present you the main elements of our project, which has the title of Storage Innovations for Green Energy Systems, and it aims to design, develop, and apply an energy storage toolkit, the SINO toolkit, that will provide a complete approach for the management of different storage technologies, different innovative storage technologies that cover a plethora of sectors and applications that involve widely adopted and commercialized options like hydro-pumped storage and lithium-ion batteries, as well as emerging technologies here in the R&D phase, like power-to-gas, like redox flow batteries, and try to cover a wide range of either long-duration energy storage or short-duration energy storage. These technologies have a significant diversity in terms of their operational features and technological maturity, factors, of course, that will significantly impact and influence the respective integration into the power grid. Next slide. Here we present the technologies that we develop and demonstrate in our project, that are different depending on the average duration and the services that they can provide. We have ultracapacitors and flywheel, lithium-ion batteries, flow-based batteries, thermal heat storage, hydro-pumped storage, and power-to-gas storage. Next slide. Here we present the demo sites that we have. Practically the project has 27 partners, 6 demo sites in 5 different European countries. We have different environments and different demand sectors: industrial, residential, agricultural, mobility. Cross-energy current integration potential, coupling electricity with heat and hydrogen storage. We have a demonstration in Portugal, where batteries and thermal storage and electrolyzer is integrated into a large industrial microgrid. We have a demonstration in Spain, Soria, Spain, with geothermal energy potential for district heating in urban microgrid, integration with a microgrid. We have also a third demo site in Spain, Huesca, into local energy community and also hydrogen, renewable hydrogen generated by renewable energy. We have also a fourth demonstration in Germany, led by DLR, that studies and demonstrates optimal integration of heat and electricity storage in a small industrial microgrid. We have a demonstration in Greece, in Ikaria, the digital twin of a hydro pump storage in a non-interconnected island, such as Ikaria, together with wind generation. And also we have a demonstration in Geneva, Switzerland, energy storage in mobility applications with hydrogen fueling. Next slide. In the activities of Synogenes, we develop, test and demonstrate a variety of energy management tools, digital twins and market services for energy storage technologies that have different time horizons: short-term time horizon for intraday markets or real-time balancing markets, medium-term time horizon, day ahead or week ahead, or long-term time horizon like for planning purposes of the grid. We have also grid flexibility services, frequency regulation, black start, voltage support, congestion relief, and demand response. We have also applications on field and simulation studies for planning and operation of energy storage system locally, as well as management of hybrid storage technologies to provide flexibility services to energy system operators. We demonstrate increasing operational efficiency through energy sector coupling. We are also evaluating with digital twins the planning of interconnections between remote areas, islands, outermost regions with insufficient grid capabilities, long distance connection to valorize large-scale energy storage. We are also leveraging energy storage for energy efficiency and grid flexibility in the transport sector, which is gaining more and more importance in our daily lives. We also evaluate and demonstrate the resilient operation of industrial microgrids in energy communities, leveraging renewable energy resources and hydrogen storage. Next slide. Apart of all this demonstration, the tools, we are also having some horizontal activities in order to facilitate, to enable the wide application of these storage technologies into the power grid and the power system in general. We have dedicated activities for environmental and economic impact assessment, life cycle analysis, life cycle costing, determining and evaluating a predefined set of KPIs, of key performance indicators. We are also developing business models for these energy storage technologies for wider market uptake across Europe. And since we leverage the output and the calculations that we do for the environmental and economic impact assessment, and we conduct also a detailed techno-economic analysis of the project demonstration activities using the Artelis Crystal Supergrid modeling platform that is used also for pan-European studies, energy studies. Next slide. Here we present the methodology, the stages of the methodology of the project. First, we had the pre-development phase, which has been completed. We have the development and realization phase that we are currently today, where we develop the Synogenes tools, when we are developing the ICT architecture, when we are preparing for the field deployments and the integration with the grid. Then we will carry out the demonstration campaigns, the business validation of the demonstrations, and the evaluation of the KPIs. And at the end of the project, the final year, we will do the valorization of all the outcomes regarding environmental assessment and impact evaluation, the pan-EU system study, and also scalability, replicability of the technologies, and also the exploitation of the Synogene's solutions. That's all, I think, from my side. The final slide, you can see the consortium. It is a big consortium with many technology partners and system operators. Thank you very much for your time.
Thank you very much. So shortly presenting TULIP. TULIP, it's the fourth project funded under the same call of the other three ones. And the project proposes to accelerate the green transition by adding state-of-the-art energy storage technologies to existing power plants, enabling them to turn fluctuating renewable energy supply into stable, reliable energy supply. The technologies offered by the projects are high temperature salt storage that meet the utility owners to phase out fossil fuels and phase down biomass without the risk of losing grid, enable deployment of low-cost, high-efficiency energy storage, and enable renewable energy storage to provide short and long-term supply stability to the grid, thus helping European countries integrate more renewable energy without the risk of blackouts. The concept is given to us by this scheme here, and the idea is that we convert traditional electricity and cogeneration plants away from fossil fuels, as I was saying, to convert traditional electricity and cogeneration plants away from fossil, and to reduce the costs of energy storage by reusing an existing infrastructure. Bringing back the technologies offered by the projects, by this project, we have here the second life batteries, the swing joule, and this salt layer. So that's it. I'm sorry I couldn't be very long in explaining TULIP. I am not part of the project team, but it was important to give you some highlight of the project. And now, without further delay, I invite Rita to lead this interactive discussion together with our three other experts, who are Pedro Rodrigues, Gianluca, and Elias. Please turn on your cameras, and Rita, the floor is yours. Thank you very much.
Thank you so much, Anna. So we'll start by very briefly presenting the panelists who will be discussing these topics. So we have Pedro, who leads the Unit on Intelligent Clean Energy Systems at LIST, the Luxembourg Institute of Science and Technology. He does research on topics such as power converters, intelligent energy systems, distributed generation, and universal energy access. Then we have Gianluca, whom you heard present one of the projects. He's the technical leader and European project coordinator at the Electric Power Research Institute Europe, and has been doing work on digital energy and cyber physical systems, monitoring and automation, and data-driven approaches for electricity grids management and operation. We'll have Elias, who you also heard, who does work on simulation and reliability engineering and on power systems, and he's the technology director at UBTech Energy. So we will discuss some of the topics. Maybe I can already invite the audience, if that's okay, Anna, to use the Q&A box to ask any questions if they want. And then we can take a look at those. So feel free also, if you have questions about the projects that were presented, that is absolutely fine. Because this is such a huge topic, and I think very relevant to energy. So the storage solutions are front and center of allowing us to push forward in this domain. Maybe we can start with battery storage technology. So in whatever order, maybe we can start with Pedro. So what recent breakthroughs have been made in battery technology that could really push forward the energy storage?
Yes, now I am mute. Okay. So, well, batteries, specifically talking about batteries. Well, the main challenges now is to try to overcome lithium. Okay. I mean, lithium is one of the issues. I mean, the matter technology and so on. Well, sodium ion is performing interesting steps. Okay. And already almost mature. Okay. I mean, technology which is ready already for mass production. Let's say we can also talk about lithium sulfur. It's on the market introduction still today. I mean, not yet. I mean, because yeah, yes, market introduction, core transaction. Therefore, the main issues were in materials. But if you talk to me about the main progresses, okay, in addition to other technologies, I don't know to talk about the nickel zinc or nickel bromine, okay, but of course, vanadium redox flow batteries, some of our colleagues mentioned as well, vanadium redox flow battery, they are progressing a lot, they are increasing the power, okay, and they are already in a point that, they start to be already going for real cost reduction and competition. But the main, in my opinion, in terms of batteries, the main progresses were in the level of, let's say, potassium air or magnesium sodium, okay, the new technologies for sure. Graphene dual or graphite dual ion technologies, aluminium air. In the MIT, there is a very strong group working on that now. It's a promise. Therefore, there are very interesting technologies that could allow really to reach the goal at the end. Okay, but still we need to wait. Probably still, I don't know, 2008, 2030 to have all these technologies really available. But the steps from the conceptual perspective are very important. I will not extend myself as well on other aspects regarding control, operation, and so on. But talking specifically about batteries, I think these fundamental steps gave rise to very, very interesting breakthroughs. Okay.
Thank you so much.
Thank you so much.
Ilias, do you agree, and how do you think these advancements address key challenges such as energy density, costs, and or lifespan? Some of the topics that Pedro already raised.
Yes, I completely agree with what Pedro mentioned. I think there are many interesting technologies that are now under, let's say, development, under evaluation in the laboratories with different TRL levels, with different applications. For sure, the mobility sector will lead, let's say, the developments in batteries because it is a great interest there for the electrification of mobility. So there we expect very interesting results in the future, in my opinion. Also, we will have to see also in wider scale how batteries can support, let's say, the consumer applications with PV battery hybridization at the consumer level. This will be also interesting, and also to see also the life cycle assessment about application at consumer level. This is also another interesting aspect. And of course, we are still expecting great changes in the coming years.
Yeah, I agree. This is a fast-paced area at the moment, right? Following this, Gianluca, and picking up exactly on what Ilias said, and he mentioned the consumer, and I wanted to ask if you think, are there any specific areas or applications or even verticals, industries where these advancements are expected to have the most impact or are already more advanced than others?
Yes, that's a good point. I guess everyone, the first thought when talking about batteries and storage, probably it's about the electric mobility. That's known to everyone, how much is growing, and also probably posing many challenges in terms of scalability of the technologies, or for example, the density or the cost reduction and so on. From the perspective also, let's say, leaving behind the electromobility, if I think about what we look from our project, I see, for example, green hydrogen production as one, or in general, whenever there are let's say legacy processes that are not so green, let's put it like this, and need to, for example, combine different sources, energy sources, especially with renewables that have their characteristics, advantages and disadvantages, and have to maximize those. The combination with the storage to support this green transition is crucial. We see it in our project. I think also in the other demos, we saw some examples where the usage of the storage can enable facilitation of processes that normally are relying on less clean energy, or that maybe could have characteristics that can be leveraged, for example, for supporting the grid. So if there is the integration with the storage and the specific type of loads or processes, then alleviating the grid needs or supporting the grid when needed, it's also an area that definitely is already benefiting from storage and will more and more benefit from the different type of storage that also in our project are being developed or validated.
Great. Just before closing this, I wanted to come back to Pedro, because i-STENTORE also has addresses several verticals. So do you have any input on if you think, is there any industry or any vertical that is more advanced in the adoption than others?
Well, yes, in my opinion. I mean, the matter is, yes, okay. I mean, but the main driver here is, let's say, batteries are just bottles for storing, or special bottles for storing electrons, and now we are in a step that sophistication and specialization is the key, okay, for really going there. When you talk about the sectors or the business model and the opportunities, I consider, well, the multi-technologies, as my colleague mentioned, the PPAs with multi-technologies, integrating batteries in the middle, hybridization, integration is very important. Second life applications, okay, in few years we will have a lot of batteries from electrical vehicles to be reused. That is clear. I mean, hybrid system, as I mentioned, data centers has a lot of energy today that can be used, energy storage, to be used in services, and not only services for frequency regulation, but also services for improving, let's say, use of energy in a rational manner, energy community, and so on. Fast charging infrastructure, they will need batteries, okay? The fast charging is impossible without local energy storage or without new infrastructure connected to medium voltage. As you know, all the new retailers for zero energy facilities, virtual power plants. So in my opinion, there are several sectors specifically identified where batteries will be very clear enabler for developing the new businesses. Okay, of course, in combination with two additional technologies, batteries will not be as possible to develop any kind of business case without digitalization and without artificial intelligence. That both should be hand by hand with the batteries. Okay, in my opinion.
Okay, and coming back to those enabling technologies, which are
very important.
But picking up on what you said, that batteries are kind of empty bottles. So I would like to talk a little bit about the potential of solutions such as compressed air and hydropower storage that your projects are also addressing, and that I think are probably less known to most people nowadays. So maybe starting with Gianluca, because you presented, for example, even in your project, these aqueous electric recuperators and irrigation systems. But can you elaborate or explain a little bit how these hydropower storage works as energy storage solutions, and if you are aware also how any compressed air solutions can be used as energy storage?
Yes, maybe in our case, it's quite peculiar what we are trying to do. It's different from, for example, the pumped storage you normally would find in an hydropower power plant. So in our case, what we are trying to do is there is an infrastructure which is meant for the irrigation of the fields, basically in this demonstration site in Spain. So there is an infrastructure for moving the water, for storing the water, and of course you always have pumps to move the water between the reservoirs and the canals. You can also use, for example, reversible pumps, which means you can change the direction of the flow, and you can either pump something, so use it as a load, or reversing the flow, using it as a small generator. All this infrastructure that is there, let's call it a legacy infrastructure in that case. The idea in our case was to reuse this opportunity to create some sort of long-term storage, where you can during the high peak demand, spring and summer, basically, being a quite seasonal use case. You of course need to make use of the reservoirs you did. So you mostly have consumption in that case, not so much storage from the hydro. And there it's important the combination with other sort of storage. For example, in that case, we have electrochemical storage to support the operations. While in the low peak demand, what we try to do is we have the reservoirs and the canals. Why don't we use these as a way to serve, for example, the grid in that case, by reversing the pumps and generating when the grid is in need, or maybe using the reservoirs as a flexible loads when there is an excess of generation, and we can store in a different, let's say, mean rather than electrochemical storage something. And that's useful in this use case because the community, the biggest operating costs are indeed the electricity ones. And so by leveraging an existing infrastructure, so reducing the investments and being able to reduce the operating costs, it's a win-win situation for this type of use case, which is quite widespread. For example, in Spain, there are multiple irrigation communities. So in general, apart from this specific use case, I think there are many cases where there is a, let's call it, legacy infrastructure. For example, the irrigation canals in this case, that can be reused for a different sort of storage that can be combined with other storage solution and serve multiple needs in different time frames also. Which is a way to, as Pedro was saying, and the business cases are multiple in numerous areas. It's also up to the users to find out what can be leveraged and how the combination with the storage can enable something additional. So new revenue stream or reducing costs. And so make it more sustainable in that case.
Yeah, I think that's very important. Ilias, you also mentioned these hydro pumped in Senogens. Can you elaborate a little bit on how your project is using it, and how do you see these implementation and application?
Yes, practically we have a very interesting case regarding hydro pumped storage together with wind generation. It is a hybrid. It is a really, let's say, I think there's another one. There are only two, let's say, in Europe, one in Spain, if I'm not mistaken, wind with hydro pumped storage coordination. And practically what we intend to do there is to optimize the operation of renewable generation together with hydro pumped storage in order to support the grid needs and let's say support the decarbonization of the island, as well as maybe even evaluate and examine some planning studies for interconnection with nearby islands in order to fully valorize the great storage capacity that it is in the Ikaria island. This has been also something under consideration in the development plans of HEDNO. The interconnection with Samos. This is also another case that we have there in order to fully valorize the wind capacity from the Samos island as well, because the capacity of the hydro pump storage in Ikaria is really big. These are just, let's say, ideas and scenarios. The main core is just to develop a digital twin of the wind and the hydro pumped generation in Ikaria. This is also a very interesting case because hydro pumped, as also Gianluca and Pedro also mentioned before, is very important, and I think it gets even more, let's say, interest as they can really support the grid, and there are also installations across Europe that we can also valorize even more now in order to store energy. And also another interesting issue would be also to valorize abandoned areas like maybe old mines or other areas in order to develop even more hydro pumped storage installations, because it is very difficult, as everybody knows, to develop from scratch a hydro pumped storage plant. So the more we can get from the existing installations, the better.
That's very interesting. So Pedro, following these, and because Europe is not the largest continent in space, but it is very diverse, right? In terms of weather conditions. And so how scalable are these technologies at the moment? And are there any factors that will influence their application on the field?
Yes, well, in Europe, I mean, the matter is, yes, Europe has interesting particularities. Okay, we have wind in the north, we have a lot of solar irradiation in the south, we have hydro storage in the Switzerland, in the center of. So storage energy in the center of Europe could be, because many people is talking about the storing energy, molecular energy, and producing energy in Morocco. But how we will later in Morocco, where are we going to use the hydrogen at the end? Okay, so probably it's better to integrate renewable energies from the north of Europe, from the south of Europe, to storage energy, also in Norway, of course, but mainly in the center of Europe, and generate maybe large large storage centers. Not only talking about batteries. Batteries is a very flexible component that could be stored wherever. Therefore, in such a case, maybe Europe will not be a part of markets, clear differences respect to what happened probably in America or in Asia. But regarding large-scale storage, the one that will be giving rise to the energy transition that is urgent to be faced here in Europe, the big, let's say, one of the big bets could be to do that, okay, to this particularity. Okay, we have the large consumption centers in the center of Europe, storage for smoothing variability, wind in the north, solar in the south. So probably center of Europe, okay, where interesting nodes are there, interesting north-south HVDC connections are already under development. So probably that would be an interesting particularity of Europe for driving storage, okay, in the long term, the thinking on storage on the beyond of, let's say, the day ahead storage requirements from batteries, okay, but thinking on other, let's say, seasonal or long-term storage that is really what we need for really transitioning. Okay.
Right. One thing that I think the three of you mentioned, and it's quite interesting, is that there's no single technology, but integration is key, right? You mentioned the integration of several technologies, either to produce energy, to store it, and so on. So Gianluca, maybe coming back to you, what do you think are the main obstacles to integrate these innovative storage solutions into existing grids?
Let's say there are, and also recently, that there is a lot of activity on regulations about the integration of storage and renewables. Let's limit it to this. All sort of storage. There is also a lot about EVs, if you want to consider those, from both sides, the storage and also the charging infrastructure, as Pedro mentioned, that is crucial. So recently, there is right now in discussion the new, let's say, grid connection codes, which are being finalized now. That, of course, has been updated to consider the storage and the generation, also the combination of the two, which is one step, because it was needed to do these updates and see exactly what it means in terms of regulations and codes to qualify, for example, the storage for specific applications or grid services. Of course, we have a diversity also of regulations then within Europe, even though we have some common guidelines. So for exporting use cases within different countries, maybe that could be not an obstacle, but something to be considered. How then the local regulations enable, for example, the porting one-to-one of solutions developed or tested in one country to another. It's not only a blocker. I think that the attention that is being put on the grid codes and the regulations is also an opportunity, because it involves many stakeholders in defining these grid codes. So as long as all the involved parties and stakeholders are involved in the decision making, in the discussions, then there is the opportunity to see if something was not considered or not fully considered, if there is the need to additional discussions on how to boost, if not only allow, but boost the adoption of a specific solution. So it's an open discussion. It's very interesting. I think it's relevant for all our projects, especially when you want to go from the validation in demo cases into real products, or let's say business applications or widespread, and so it's an aspect that has to be kept in mind always when developing solutions, and then when deploying them.
Great. Ilias, I wanted to pick up a little bit on this and expand on impact. That we, in your opinion, in what ways can these innovative storage solutions support the sustainability goals that are always being discussed? So goals such as reducing greenhouse gas emissions, promoting a circular economy, but wider goals. So what will be the role of these innovative storage solutions in achieving those goals?
Yes, in my opinion, it plays a very important role, a pivotal role, storage. I believe that the storage should be very well connected with renewables. I mean, there should be some clear models, business models, mechanisms, and regulation that enables storage to operate well with renewables, because practically in that way it can support decarbonization, and also it can improve, let's say, the dispatchability of the renewables, turning them into dispatchable generation, which is practically what we need in order to have a stable power system. I think also the latest regulation and also the legislation in the countries and so on should work in this direction, not only at the general level of renewable, of wider capacity renewables, but also in the distributed renewable generation at the houses, regarding distributed renewables and distributed storage for the consumers, together, of course, with maybe valorizing the storage from the electric vehicles, vehicle to grid service or similar. So I think this is the one element. The second element is that it should be really clear also the circularity for regarding technologies like batteries, regarding let's say the recyclability of these assets. This is also another area. And also a third area, which will be important, is to clarify what and how storage should be connected on the network. This is very important. There should be a clear, let's say, definition across Europe of what is storage and how this can be connected and treated. Not only in the sense of a private investment of people that are owning and operating storage in the market, but also storage connected and operated by grid operators. And this is something that it is also important and will be clarified in the demand response network code that is coming forward. This is also will also support the sustainability because it will support the stable operation of the network and also the greater penetration of renewables. That's all for me.
Thank you so much. So I will ask one last question to Pedro before we wrap up. President von der Leyen in Davos last year, in the World Economic Forum, she said that she wanted to make Europe the home of clean tech. And you mentioned the importance of this energy transition that is desperately needed. And we want to be at the forefront from that. If we consider that we're doing all these technology advances, is there anything that you think is missing from the policy-making side, either at European level or national and regional level in our countries?
Well, good question. And serious question, yes, because we talk about policies, okay? I mean, yeah, this is why, I mean, the real issue, I mean, the matter is, I think this energy transition for sure, energy storage is the solution. As Elias mentioned, renewables would not be possible. I always said the strongest enemy of the energy transition is the solar power, because solar power is there when it's not needed. Okay, I mean in the middle of the day, but in the morning and in the evening there is not solar power, and it's the cheapest technology that we have today and probably the future. Therefore, energy storage is the enabler for, of course, integrating with other solutions and so on. But this is not only a matter of compensating, pushing here, everything there. The game is completely different. We are talking about a different game. And this is probably what politicians are not understanding, okay? The current energy game is over. We should think in a completely new paradigm that will allow this transition that we are mentioning. We cannot maintain verticalities, artificial verticalities. The players that are today in the system probably will not be anymore in the future. Even they try, but probably not. Okay. Therefore, policies. Europe is making a big step regarding the energy transition. I mean, the directives on setting the end user in the center of the problem. This is the approach. Okay, and growing from there. Therefore, the matter of the regulation, for sure, regulations should be. Regulation are today, are the barrier for the progress on energy transition. The driver, the cost. I mean, the batteries are here. I mean, solar is here because the cost is really cheap, and batteries very soon will be very cheap as well. And that is not because of regulators; it's because of industry. Okay, and regulators are not able to follow in many cases. The rhythm of the industry, but in addition, many times we are not able to understand what is the new game we are playing on. Okay. And this is the main issue. This spirit of a European energy directive, end user in the center of the game, that is the approach. Okay, it's not a matter of maintaining existing infrastructure. It's not a matter of continuing with market rules that we know. Of course, it's necessary to be a little bit more risky, but the approach should be a bottom-up with center, or bottom-up, top-down, but not the typical one we have today. The rules are other, and regulators. Yes, they should be risky. I mean, there is a lot of uncertainty. Just but time is running, and the evolution is going very fast, and the transition is something required not for 20 years ahead. It's for tomorrow. Okay, so
yes,
it's something that we should really make actions, pay attention. Don't overpromise too much. We are overpromising many things, and many times this is something we are raising expectations. Investors are injecting a lot of money, and later when there are volatility, suddenly we found disasters. Okay, therefore it's necessary to really identify what is possible to do and not. But yes, the matter, as I mentioned, I think the bottom-up approach, user-centric approach for integrating energy is one of the issues that we should really pay attention as soon as possible from energy communities, from because to grid, okay?
Yes.
So.
Yeah, this is a challenge, right? The policymakers keeping up with the pace of technology. This is always a challenge in several areas. I think you mentioned something very important, which is communication to the end user as well. And these projects have a key role in these, in letting know or communicating to out there what the technologies that are being developed and their applicability, their sustainability, and so on. So thank you so much, the three of you. We could continue for a longer time because this is a very rich environment, but it has been amazing, and I think we have a lot of insights to follow up. Anna,
Definitely. Thank you very much. Thank you all, four of you. Back to me. I'm very happy for this discussion, and we can feel there is so much more to discuss. And yeah, so I give the floor for the next energy talk that is scheduled for the 29th of May at 11 CET. Please, you can register by scanning this code that you can see here, and we will be discussing about the bridge between industrial needs and grid codes. That is also quite interesting, and we look forward for the discussion. Thank you all for today. It was a great pleasure to hear you and to have you with us today. Thank you very much. Have a great week.
Thank you.
Have a
Bye.
great day, everyone.
Bye.
Thank you.
Bye, everyone.